All right, so some basics to start with. It is a microwave emission device for the radar side. Now, safe health and safety precautions for that, because it is a microwave emission. Do not hold that against your body. So the emission's coming out of the bottom face of the unit. So I suggest if radar's on, don't go holding it here, looking directly into it. Don't go holding it on your body anywhere. And with the laser pointer that comes out of it, as far as the thermal sensor, obviously you don't want to be pointing that laser beam directly into anyone's eyes as well. So pretty basic, pretty much common sense there as well. But we do need to mention that, okay, as far as that safety is concerned. All right, so the Itraker and predominantly Termatrax over the years, it is not a tool that's going to do it for us. It's an inspection aid. All of these tools, even getting down to the most basic moisture meters, they're a companion tool, and that's the way we need to look at them. So we still need to do what we do on inspections. We still need to go around. We need to look, feel, touch, listen. Everything that we're doing so far on inspections, you need to continue doing. And then we use our companion tools, whatever that may be, whether it's the whatever sensor on the Itraker, or whether it is a basic moisture sensor, or whether you're running a standard thermal imaging camera. They're all companion tools at the end of the day. So apart from knowing our target, knowing the ins and outs of those creatures that we're hunting, but also knowing the equipment we use, it's utmost important all around. So at the end of the day, what we've got to remember is we're the professional on site. The clients are the ones paying us for our opinions and our findings and our knowledge at the end of the day. So we've got to be professional and do everything. Couple your companion tools in to make it to make that inspection process better for your client. All right, so Itraker software, it is free software. It's free download through the Apple Store and Google Play. So for those coming from T3i, that's a big change, that we have finally been able to get Apple connectivity going on there. There's been a hell of a lot of hoops to jump through with Apple, but it's finally there. So I believe that is all up and running and ready to go. So if you're looking to come on board with it and you're running Apple devices, that is a good thing for you. You do not need another device or an Android-based device to make it all work for you. Now, there is all updates and so forth going on, but there is a subscription, if you will, for the Itraker after purchase. And it is the IT Care subscription, so that covers any software updates that's going ahead, moving forward. Now that is quite cheap. I believe that you're only looking at $120, $130 a year for that, but you're getting everything for free there. That looks after all the back end for us, and there's quite a bit involved from the Termatrack end on that as well. Whenever Android or Apple do updates, the Termatrack apps now have to be updated and checked to make sure everything's compatible still with the new updates that they put out. So there is a bit involved with it now. Hence, it's gone to that the monthly subscription. All right, so obviously everyone at Termatrack here is wanting to help if you need it. So don't feel that you're buying a device and then you're out in the cold. There's plenty of other devices out there in the market for our industry that it's go hand over a wad of money and you're on your own. You got nowhere to turn, you got nowhere to ask advice or help on it. Termatrack operates in the way that everyone here wants you to know how to use the device. So if you do have problems, ask the question, shoot off a support ticket, or the phone numbers. You probably all have Victoria's contact numbers or the office numbers here. So please make that call. If it's anything that can't be answered by someone in the office here, they will refer that on to me. So generally what they'll do, they'll either pass your details on to me, whether that's email or phone, and I will be in touch as soon as possible, and then we can discuss it further, whatever that issue may be. So, and that's all part of the backup that you do receive from Termatrack. So it is one of the, as far as companies that we deal with in the pest industry, I personally believe Termatrack's one of the better companies for as far as offering support to their clients. All right, so the Itraker suite. All right, so everything that you need to make it work is in there. So you do have the Itraker device itself. Obviously, the big yellow thing. Now, a very cool feature which there is it's the Itraker stand, if you will. So there is a magnet built into the back of the units now. So these little stands just clip on the back, and that comes into as far as positioning, standing it upright, or you can flick the stand around if you need to change the height of the radar and so forth. So any which angle it needs to be. So that stand is very good in that sense. But the magnet on the back of the Itraker as well is you can put your phone on there. Okay, so that can make it, and obviously twist it whichever direction you need it to be. Now that can make it a bit easier in certain scenarios, having the magnet on there. It's not for every situation being on there, but it certainly is it's a handy little addition. Don't lose this, by the way. It looks like a tiny little item and so forth, which it is, but again, it's a nuisance if you do lose it. So I suggest not keeping it. Don't just keep it on the device all the time. So if you don't need it there while you're using moisture, for example, take it off, put it in your pocket, put it back in your little kit box. It saves that issue of losing it down the track. So as you can see here, there's also a lanyard. Obviously, we know what lanyards are for, putting your hands in and hanging on. Obviously, slippy fingers, you're not going to hit the ground with it. Now, there's also a backing plate. So that little black disc that you can see there, Termatrack written on it. So that is for going onto the back of phones that do not have a metal case. As such, a lot of the later model phones, they are all metal cased anyway. But if you do have a little earlier one, or you have a cover on it and the magnet's not working correctly, you can stick that magnetic base onto there, and then that's what gets your magnet to join onto the unit itself. You do get a USB-C type charging cable. So the charge port for the Itraker now is USB-C. New phones, it doesn't matter whether it's Android or Apple. You'll note that they are all USB-C, the late model ones now. So I believe that's a worldwide thing. Apple has been forced, I know at least by the European Union, that they can no longer be changing charge cables at the phone end. It has to be USB-C. So again, we can sort of get away with one charge port, one cable really for multiple devices, looking at it like that. There is a user guide that you will have in there. I believe that's a downloadable one that you get, plus your 24-month warranty card. So obviously when you get the kit, obviously have a good look in it. Make sure that all the components are in there. If it's not in there, obviously it's just a phone call or an email, and the office will see what's going on there and we'll get you hooked up. All right, so as far as penetration goes, not a lot has changed here from the previous model. So we certainly will get successful penetration through these items on the screen we're seeing at the moment. So tiles, marble, stucco or render as we call it here in Australia. Your drywall, plasterboards, we'll go through those. Concrete blocks, certainly will get to the core of those. It's not designed to go all the way through a concrete block that's core filled. 190mm concrete's not going to allow that to happen. But getting to the core in between mortar joints certainly is successful. Granite, marble bench tops and the like, good penetration to those materials. They are quite porous, so you do get some good penetration. Masonry materials and obviously bricks we'll go through. We'll go sideways through a brick, so 75mm. of the brick, it certainly can go through that. Obviously, signal reduce, but it will work. Are there many situations we need to do that? Not really. However, the ability is there to do it. Obviously, roofing tiles, shingles, and the like. Obviously, the states are a little bit different to us here in Australia and other parts how we do our roofing construction. They tend to have plywood, ply base going down on top of the rafters, and then put some funny looking black tar stuff, and then throw in there what they call shingles, laying them down, gluing them, so forth. So very easy to go through those actually. So for drywood termites and the such, if they are in that the under shingle or the under roof lining plyboard, you can certainly pick up on those from the top side if you feel the need to. Particle board, chipboard, pressboard certainly penetrates through there, no issues. Your carpets, underlays, and the like, no problems. Insulation, again, no problems going through that. Now, it will penetrate foam insulation, so the spray-on foam type, which is, for whatever reason, it seems to be quite big in Northern America. In certain areas, it's essentially, at the end of the day, it's not a nice thing to be going to put on your house for many reasons. At the end of the day, but if you are in a situation where you believe termites are tunneling through it or are beyond it in the timbers, the Termitrax certainly will work and penetrate that material. So plastic piping, conduit, and the like, there's no issues with penetration. And then our timbers, obviously. So it's obviously various depths depending on the type of timber you have. Is it a softwood? Is it a hardwood? You will notice there's different penetration levels depending on which way you are trying to go through the grain. So if you're going with the grain as such or against the grain, you will get differing penetration results there. Obviously, hardwood timbers, you do not get as much penetration as you do on softwood timbers as well. So as I said, everything does have limitation. It's up to us to understand what that limitation is, and knowing construction of the building we're inspecting is one of the biggest things. We need to know that, what's behind the walls, what can create an issue for us, and so forth. So the two main issues that we've got with the radar side of things on the device, moisture. So moisture actually absorbs the radar emission. What that will do to us on our display screen will reduce the signal for us. It'll get smaller and smaller. That's happening purely because of that absorption of the microwaves. So as the microwaves are going into the moisture area, it's being retained or absorbed, and it's not allowing the signal to come back out to give us what we need on the screen. So depending on moisture content levels in materials, you can overcome it by adjusting the gain level on your device, on your Android or your Apple, which is like a volume button essentially. So you can get an increase with that. However, we're going to get to a level of moisture where we're going to reach basically total absorption, or enough absorption that we're not going to have a significant signal to be able to interpret the data from. Now, that moisture content, we're looking at around that 25% or more mark. Once you run moisture sensor along an area and you're getting those levels, don't worry about putting the radar directly on that moisture area, because you will not get an adequate signal back. Okay, we can work around that, doing some other tricks, which I'll discuss with you. So it's not really a big deal at the end of the day, not being able to get penetration in those high or the elevated moisture areas. Okay, but it certainly can be worked around. Also, what we're going to see as it can be an issue is metallic materials. Radar or the microwaves cannot penetrate or go through any metallic object. So if you're using the device and activity or movement is between the metal and the device, it'll certainly pick it up. But if the activity or movement is beyond the metal material, well, you're not going to pick it up. It's only going to hit that metal. Where that can create some confusion when we're using it is you can get some bounce off metal objects. So if we're not hard up against the metal, so for example, we're going from the internal side of the plasterboard, and then we have a gap out to the outer side of the studs, where, particularly in Australia, we're running a sisolation product, which is a foil essentially. So if you're going straight through the plasterboard void onto that, it can bounce the signal, and you get all sorts of strange and weird and wonderful patterns going. So again, it is about knowing what material is in there that can create that, but then also it comes down to our interpretation of the data. So looking at the data we receive, that is how we can make our assertions as to what that movement is. And there is a difference. You will happen to notice the irregularities of metal bounce as opposed to what termite patterns actually look like. All right, so positioning of the eye tracker, obviously it needs to be where we need it to be. That's probably the easiest way to say that to start with. It's not a device where we're going to be walking around a room, just pointing it around, thinking it's going to work for us. Excuse me. So it does have to be positioned flush against the material that we're wanting to test. Look, it may work with a little bit of an air gap. So if you are a little bit off the material, in certain situations, due to positioning or other items, you may have to do that. If you do that with an air gap, we've got to be very mindful because as radar or the microwaves try to penetrate material, there is a certain level of bounce, depending, or emission bounce, depending on whether it's smooth, glossy material and so forth. So that can be a little bit issue not being flush. So we always recommend where possible be flush, and that's going to allow us for the maximum microwave or radar penetration on that particular material at that moment. Okay, obviously we don't want it to move, but for those of you coming from a T3I, you will notice the shape of and design of the unit now. It's a whole lot easier to hold steady and use the device now than the T3I was. It's not top heavy. As you remember, the T3I, we used to hold it on sideways with everything on the bottom, and it was quite lengthy, and the weight wasn't exactly balanced correctly, if you will. Whereas this one, it is very easy to position anywhere you like, and it's literally even one finger pushing it against the wall is enough to hold it steady. So that's a massive advancement coming from the T3I. Now, I've mentioned about having an air gap between the unit and the material, and we can get some emission reflection. Now, that can also happen if you are holding it flush against very smooth, glossy material. Predominantly, it's tiles that we tend to get this issue from. But anything very high gloss, smooth finish, it can create this issue. Where what's happening is, as the radar is emitting from the device, even though we're flush up, there will be a certain amount of what we call emission spill, where the microwave emission will travel sideways or outwards along that smooth, glossy material. Now, if you are using it on those materials, a few ways we can work around that. Obviously, the easiest way is position your tool and you move back from it. So don't have your hands near it, other people walking around, so there's no way that it can detect that. Or what can help is a piece of cardboard. I don't have one here, or I do actually. So on the back of notepads, big, large, small, you have that little bit of cardboard there. Having that with you, and you can utilize that cardboard to go between the eye tracker and that smooth, glossy material. So it's the cardboard against that material, the eye tracker up against it. What that cardboard does, it allows the microwaves to penetrate through it by reducing the amount of bounce or reflection, which then in turn reduces how much sideway spill across that smooth material. So that's something which doesn't take much to keep in your kit, but can be very handy when you certainly are using it. All right, so the little stand I was talking about there for you. Obviously, you can see those pictures there. Obviously helps us with that positioning. If we need to stand it upright. The radar is down here. I want to stand it against the wall. Without the tracker, you can see the little stand for the eye tracker. It's not gonna stay upright. All right, it's always going to fall. So that's where that stand comes in perfect for that. Whether or not you can see down here on the table where I've got it. So it does stand nice and comfortable. And as I said, that can be moved to be the other way, which is then moving the radar to the top section. So that's giving you an extra 4 inches of movement straight away. Obviously, there is some devices there that we can utilize. There is a nice little tripod that you can get with an outrigger on it now. Obviously, these things, they are designed for professional cameras and so forth, but the little outrigger on it that you can put your mobile phone into now, that's a great little tool in that sense. So you can have it all set up in front of you. You can move back and you can still see the screen there in front of you. If you want. Obviously, Bluetooth works for some distance, so you can handhold it if you want, if you don't have this new little tripod. At the end of the day, it's always been the same with the radar. Get it to where it needs to be and don't have it move. Right? No reflection, so be mindful of what's around you, the material we're going through. Do we have curtains or curtain cords swaying in the breeze? Fans blowing around, pot plants, all of that. So we've got to be mindful of that. Name of the game, get it to where it needs to be. Make sure it's not moving. All right, so turning it on, as I said, just tapping the button, we'll have green flash on that top light, power button. We open the app on our phone, whether it's the Apple or an Android on there. And then it's just a matter of connecting it, if you will. It should automatically look to connect to your device as you open the app. If not, it's just a matter of going to the top of the screen. You'll see on this picture in front of us, it's got that green box drawn around the top of the phone. So in there, we're getting the device information of the eye tracker and so forth. So that's all your serial numbers and model number, app numbers, all of that type of thing, versions. We get the battery status in there. So that's the battery status of the device itself, of the eye tracker. Again, it's a non-removable battery out there, so it is just a plug up scenario. It does not work on wireless charging. The magnet in the back of the device won't allow us to do that, but plugging the cable in, no great issue. And also in that green box, you'll notice there's a symbol for Bluetooth, so that'll tell us whether we're connected via Bluetooth or not. So if you don't automatically connect, or you're connecting the first time, you may have to tap that little Bluetooth button to enable the search for the eye tracker device to get it fully connected. Then the green light will change to blue. All right, so what we're looking at there, that is using the device. Now it's a test wall we have here. We do have a colony of termites. And they are within that wall and certainly smashing that skirting board down the bottom on that you can probably see the damage there. So that is an actual pattern that we did pull off that test wall some time back. So they are, for anyone interested, they are microceratermes in this test wall on it. So look, we do come across them quite often in buildings over here. So forth. So look, the patterns are all very, very similar with termites, which is a very good thing. A few little subtleties and nuances going across the genus. So as you can see on the screen there, it's very similar to the T3i. The upper section is the radar with the signature pattern or the line wave. Then we have the bar graph underneath it, which is the instantaneous movement blue flash. And then we have the shake section. So obviously if this is moving, that's where we get something in the shake section. Beneath that, you have a gain level function, the yellow line with the big yellow dot. Moving that forward, that's your volume button or your gain adjustment. So that's going to move your patterns, create it larger or smaller. So that's a matter of adjusting that till the volume's correct, basically, is the easiest way to say it. And you can switch between whether it's a combined line wave and the instantaneous bar, or one or the other. So looking at the features, we just click on each one that we see there on the screen. So on the base model, radar, moisture, temperature, photos, jobs, settings, support, and exit. So a couple of things differing on there. The settings button is right in front of us on the main app screen now. We don't have a little option button you've got to find on your particular phone to go through it. All of that is on there on our screen, nice and easy for us, even getting into your jobs. So if you are loading clients into the system, into your ThermaTrack system, that's where you can find those. And saving logs as well. If you want it saved to a particular client, you have their details in, and that's where you can find those things there. Another big difference that we've got on the screen there, as you'll notice, is the photos button. So what that'll obviously do, that'll utilize the camera on whatever phone you happen to be using, but it's taking it through the app. So you don't have to exit the app to open your camera, take the picture, and then it just gets stored on your phone wherever you have it stored. So it's actually through the app. It's just onto that home screen then. Hit the photo button, you can take that photo. What it does for us, which is kind of handy, is any recordings of scan logs on whatever sensor or photos that you take, it will put them into specific galleries. So it'll call it an Itraker radar, or Itraker moisture, Itraker temperature, or the Itraker photos. So that's all collated in one spot, which makes it very, very easy for you. All of those can be uploaded to the ThermaTrack cloud if you're looking at doing ThermaTrack supplementary reports as well. We can also edit photos and scan logs. You can write on them if you want. So you can circle items on that screen which are a concern or which you're trying to bring to the attention of your client. So even with the photo of whatever it may be, you can then write on it exactly what it is on that photo that they're looking at, so forth. So nice little handy addition to that. All right, so sense, as we keep mentioning, hold it flush against the material wherever possible. Obviously position your phone where you can see the screen. All right, so I did mention earlier we can change in between on the radar sensor screen. That can be changed between combined graph, which is on there at the moment, to bar graph only, as shown in the figure. So it's entirely up to you. My personal preference is I like to have them both on the screen in front of me. All right, so now you can. There is a button on there which allows you to freeze the screen. Essentially, if you save it, that's where we're at. Okay, so if you do hit the save, wanting to save a log and so forth, what that button will do will actually freeze the screen, and you can see that on there as well. And that's the logs that do get saved. So if you are detecting activity, you're confident that it is termite activity running through there. Obviously, saving that log is a good one. And that's where the pictures come in handy as well. Having that ability through the app to do that. You can take a picture of the actual area that you're using the ThermaTrack, or if there is visible damage in that area, you can take those pictures and then you can use the scan log and that picture on your report all in the same spot. Very easy for you to collate that information. Now the gain control, as I have said, it is a volume button. It's not increasing microwave output. That is constant along the line as we're using it. All we're going to be doing is adjusting the gain level is what we're looking at on the screen. So the pattern will get larger. So the line wave, which is the last 10 seconds of movement, moving from the right to the left. Now, if that's fully termite pattern or signature pattern there, and you know that, you go, great, I'll save that log, and then bang, I put it in the report. Here you go, Mrs. Jones. This is the activity on this area. Here was the picture. So there's no confusion anywhere. Excuse me. So again, holding flush on there. The radar or microwave emission does come out that bottom face, and it goes out essentially straight line. It is not fanning out. So wherever that emission's coming out, if there's movement over here or movement over here, it's not going to register because this is where it needs to be, out and directly in front of the radar section. All right, we need to move it obviously for tracking or different positions to pick up on that movement initially, but that's the way it works. So don't think that that is going out sideways and so forth. It has to be over the top of the activity directly. All right, so here's some pictures showing you the gain settings. We have on the left to the right 5, 7, and 9. All right, so if you look at the pattern on the screen, going in the upper section, the radar section there, you'll note even the blue instantaneous movement's only very tiny, but then the pattern itself is very small. It's like little ripples there on gain 5 in this scenario. As we move it up to 7, it's getting a little bit larger, 9 larger again. So what that's doing is purely it's just turning up the screen to make it easier for us to view or decipher that information that we have on the screen. Okay, there's no right or wrong level to have that on, as everyone's eyes, our focus is different, going from person to person, obviously. So what I may find good on 7, you may need it on 8 or prefer it 6. Right, and that doesn't matter. It is a very situational based item, so that depends on what moisture content we have in the area that we're testing, what type of material are we trying to penetrate, what is the activity level, if there's a lot of termites or a few termites, and so forth. So I always do suggest, though, starting on 5 or 6 if you're in an area where you really do suspect activity. And then adjusting that gain level as you need to. All right, there's no point having the gain level too low, and you're picking up something there, which could even be just resonance from slight vibration in the material itself or bounce from metal. So you do need to play around with it. Don't just use one setting, put it on, and go, look, there's something there, great, that's termites. That may not be the case. That's where we need to look into a bit more, using different positions, moving around different angles if need be, and then we make our determination from that. Just remember that we're not visually looking at the termites at this point. So we need all of that information to make our informed assessment or judgment, if you will. These are genuine termite patterns that we're looking at on the screen here, have been taken out in the field, and they've just all been saved logs that we do have. So there is some detail within these patterns that we are looking at. It is very difficult, particularly if you haven't used the device before, to wrap your head around exactly what we're looking at here and what I'm about to explain. The more you use it, the more of this makes sense to you, and you start to notice these little subtleties. The big thing with termites to start with is their patterns are somewhat consistent, as opposed to what other patterns would get from other creatures. What I mean by that consistency or consistent pattern is when we look at these patterns here, peaks and the valleys is where we're looking at. Okay, so you'll notice that we don't have, even though we're going up and down and they're going to points, not all of them are exactly a triangular shaped. You'll notice there's little step downs going into the very peak or the little valley at the bottom. Okay, so that's very, very common on termites. There's a lot that goes into why we get different patterns on different creatures. A lot of it happens to do with what their physical makeup is. So termites do have a softer exoskeleton as opposed to other insects, and as we know, that's what leads them to, particularly subterranean ones, being underground, staying out of direct heat sources, sunlight, and then regulating their humidity value or levels within their workings to be a little bit higher, to stop them desiccating and so forth. But because of that softer exoskeleton, there's actually a little bit of more absorption in the creature than we would with, say, ants. So that is why we get those little changes to the tops and the bottoms of the peaks and valleys. And then also what you notice with termites as far as that consistency goes, as we roll along the pattern, so if we start from the right side, as you look at the pattern on a frieze here, moving to the left, that's the way that the travel's moving in this sense of our pattern. You'll notice that the valley then, with the following peak, you can almost flip the screen over and they look identical. All right, so where that comes into is what happens when the radar is being slightly absorbed by the creature in there. We get the pattern, we get a slight break in moisture between the creatures and the way they actually move, then it releases, but we get almost an identical pattern on the upside. Now, that is what we've found over the years of testing and using Termatrax across the world, various situations, whether it's in field, in forestry, or in domestic situations or our lab situations. That is something that we've found to be very common and very consistent across the board with termites. It doesn't matter whether we're talking subterranean or dampwood termites, or even if we're dealing with the drywood termite. Now, I do see we do have some American colleagues, US colleagues on here. Now, when I refer to subterranean termites, that includes Eurocoptotermes formosinus, okay? I know you guys you've got subs, you've got formosins, you've got drywoods. We don't talk like that. Your formosin is a subterranean termite. So Coptotermes gets all backed into a subterranean speech here. So if you're not quite catching on there, you guys in America, that's some little differences in our terminology, but we're talking about the same creature there, okay? All right, so drywood termites. So this here is footage of the West Indian drywood termite, Cryptoterme brevis. Again, that needs to be changed. That brevis should be in a lowercase, the B there, not an uppercase. You good folk out there in taxonomy and so forth, you know how to write the scientific names. So I will adjust that for everyone. A lot of them are played at the moment, so little oversights happen, but I will endeavour to fix that for everyone for the next time. All right, so this actual footage here, this was taken by Dr. Babar Hassan. He's involved with the Australian government based out of Brisbane here in Queensland. He's with the Department of Agriculture and Fisheries. Now, he's done some significant tests on the Termatrack units over the years. He currently does have an Itraker as well. Now, his role is predominantly the West Indian drywood termites. I have done quite a few consultations and site visits with the department. So we do know the device works and works very well in those scenarios, not only for confirming we have activity of drywood termites, but also we can see a distinguishing difference in patterns between shifting frass, if you will, or actual termite activity. So these little pictures we have here, again, before I sort of talk about a little bit, if you look at the pattern, you break it down, the peaks and the valleys are very similar to what we're just looking at. So if you just quickly sort of pick even on the middle screen there, you can see those patterns there. Now, if I go back to the Coptotermes one, so we've gone from a drywood to a subterranean termite. However, we can see those patterns are very, very similar. So just flicking between them, very similar, and even going back to Shedderinotermes, very, very similar patterns. And that is just purely the way termites are built, the way termites work as such. Now, these three here, so Dr. Hassan has done, as I said, some extensive studies, primarily on the drywood termite, and how that has come about is those of us in Australia, we know what's happening with the government. over here as far as drywood termites. The government used to pay for everything, but now they're not. The governments in Australia have become very tight-ass, if you will, excuse my language, if we do have anyone that got offended by that, my apologies. However, that's essentially what they're doing. So they're putting it all out to private industry now, not taking control of it. However, Dr. San has been doing these extensive studies to be able to see what other devices, what other tools can be used as far as the detection goes of drywood termites. Predominantly, as most people know, it's you find drywood termites and the recommendation is fumigate. However, in Australia, that is a very, very costly process. So hence these experiments, testing and so forth are being conducted to find out the suitability for any spot treatment and so forth. So that is a work in progress as far as that goes. Obviously, fumigation is one and done, if you will, but you can still have issues moving forward. So hence being able to pick up shifting frass successfully and so forth goes a long way to follow-ups in that concern. But these pictures here are showing some differences that we're working on. So he has done some depth penetrations on common materials that the drywood termites are in. Now, obviously, that is softwoods. That is not a hardwood. They're not getting into the aged hardwood here. What we are finding is predominantly hoop pines, Douglas fir, and so forth. It is unsure at the moment, or jury is out, whether they actually have started getting into radiata pine in this country. If they do, that's a whole new ball game that we're going to have to deal with, but we can deal with that moving forward. Also, he's got here some pictures there showing difference between day and night time throughout inspections. And now this is a very good one here. So it's the left one we're looking at here. He's got time 0, after 30, after 60. That's a very good one for us to think about and understand, because it rings true for subterranean termites as well. Depending on the time of the year, what ambient temperatures we're getting at, termites moving into the structure, have they set up large bivouacs and carton material for temperature regulation and so forth? How far away are they from the main colony and so forth? So all of those are going to determine how many numbers they're going to be in a particular area, how fast they're moving, and over courses of time, is that movement going to change? And it certainly does. So that all leads to us is, if we do see, and particularly here with drywood termites, we're seeing that damaged area, possible damaged area, only putting a Termatrack or the Itraker on that particular area for 30 seconds or 40 seconds may not tell us the whole picture. Sometimes it's a case of setting that Termatrack up and letting it sit there. Walk away, look at some other things going on, but keeping that phone with you and periodically looking at it every sort of 30 seconds, 60 seconds and such. So those patterns can significantly change in an area throughout the course of an hour, 2 hours, a day. Okay, so we've got to be very careful with that when we use it, we're using it correctly and with that knowledge. Again, getting back to the companion tool that this device is, it's not a tool you're going to walk through a house, move it around, pointing at that wall, here, there, and everywhere. You're not going to then turn around to the client saying, I've just done a Termatrack inspection, your house is clear. You're not going to do it at the end of the day. The same as if we're doing a standard inspection, you're not going to go through doing your techniques and at the end you're going to go, Mrs. Jones, your house is clear. Well, I certainly wouldn't. I'd say there is no evidence of termite activity or damage that I've been able to detect in areas of viewing, is the way. And this is the same. The areas of viewing break down to the size of the radar. All right. So essentially, the size of the radar output is roughly 37 square millimeters. So 1.5 square millimeters. That's not that big. All right. You look at the size of the room behind me. Are you going to be able to go over every square inch of that wall on an inspection? No, you're not. Time is going to govern that. And do we need to? I don't think we do. So why would you go to certain areas, even across the skirting board? If you pick at one end of the wall, you have it there for 10 or 20, you get no activity or movement. You move to the other end, can we say that wall is clear of termites without opening the wall? No, we can't. All we can say is at that particular time that I used the ThermoTrack in this particular area at this particular angle or depth, I was registering no activity. That still can mean there may be activity 5 centimeters to the right or the left of it. But because we weren't right over it, we didn't pick it up. Was there any visual evidence? No, there wasn't visual evidence. So hence, that is our comments. We're never giving a clearance. That terminology should never be in our vocabulary in this industry. You're dealing with a living organism. They're not everywhere at every second, at every moment of the day, night, and while we're there for whatever your time frame is that you're doing the inspection. So we have to be very, very smart in our terminology and how we use it. You cannot give your clients a false sense of security thinking that because you've walked in with this, it is 110% zero termite activity in your structure. We should never do that at all. Terminology is everything, and that term saying we've got a clearance, yep, you're cleared, that just does not exist. You are opening yourself up to a world of litigation and nightmares if you continue to use that terminology, if you are using it. Okay, moisture sensor. I think everyone should understand the importance of testing for moisture within a structure. If we're doing a termite inspection, if we're doing a timber pest inspection, or if you are in the US, obviously I do know they call them WDI, wood destroying insect, or wood destroying organism inspections. So for those of you that are in America, in Australia, we distinguish between termite inspections and a timber pest inspection. The timber pest inspection is very similar to your WDO, wood destroying organism. Obviously, timber pest can be anything. It can be borers, it can be carpenter ants, it can be termites, subterranean drywood, dampwood. It can be fungal decay. All right, so all of that involved with it. Whilst a termite inspection is primarily looking for termites, we still need to look for fungal decay, moisture problems, and so forth. Now, moisture, as you all know, is the root of all evil as far as buildings are concerned. Not only for primarily our industry, looking for creatures that affect the timber and so forth. So moisture is the number one attractant for termites. Without moisture, generally you are not going to have subterranean termites there because they are following or looking for a continual source of moisture. They know that where there's a moisture area within the soil or on the ground, generally there is going to be some rotting timber if it is sitting in that area. So they are continually on the look for it. If we have moisture issues within the structure, that is just putting up a massive billboard to termites. So it needs to be looked at. Also, moisture issues come into foundations of building, ground settlement subsidence. Obviously, you're going to get foundation moving, you're going to have cracking occur and so forth. On concrete slab on ground homes, that's a big issue because it may crack the actual concrete internally, and then that allows a pathway for termites to get into the structure where we're generally not going to be able to see, or we're not looking in those areas. So moisture is a very big thing. Any termite, timber pest inspection, or any WDI, WDO should be using moisture sensors in there. It's one of the first things that we get taught through training here when we're going into the timber pest side of things, that a moisture sensor is an invaluable tool. Having an accurate moisture sensor is the utmost importance. So ThermoTrack moisture sensor is an accurate beast, and it works very well. All right, so looking at the screen here, obviously going to the home screen, changing the sensors, we flick onto the moisture on it. The screen in the middle, the big large screen, that is showing the direct moisture. All right, so we've got a dial gauge on there, which does go up to 30%, as you may notice. Now, this type of meter, we don't have probes coming off it, so it is a non-invasive meter. So we're only sitting on the surface. I will do a comparison to the Tremax style meter purely because in this country, it's over the years has been the most widely used and accepted form of moisture sensing non-invasively. And I do know that Tremex is used quite widely in other parts of the world as well. Excuse me. So non-invasive, no probes. We're not sticking anything in. It's just sitting on the surface. There is an electrical current that is emitted from the devices. So they fall, a Tremex and this device fall under the same basket or the same group of test devices. And that's a non-invasive dielectric moisture sensor. All right. So there are some differences between this and a basic Tremex, which I kind of touch on as we go through. I'm not saying the comparisons in any way to say that the Tremex device is no good. It has served the industry well for many, many years. It's served me well for many years. I'm just using that as a comparison purely because most people understand it. There is a bit to them, as basic as a tool they are, and I'll explain some of the differences that we've got. So when we're open on the screen here, moisture, as you can see at the bottom of the screen, just after that gauge, it's got a yellow button with relative on the left, direct on the right. So tapping on those buttons, you can switch between one or the other. You can switch between a direct reading or a relative reading, and I will go on and explain the difference of those in a moment. On the direct gauge, what you'll notice here above in that red box, that's a red rectangle that's drawn there, we have a timber, drywall, tiles, concrete. Now, what that essentially is a humidity compensator. So we do have a hygrometer built into the TurboTrack now. At the bottom of the device, I'll just see if slide, there we are. So if you can see where that white arrow goes, that little hole, that is the input, if you will, where the device is bringing in air moisture. So it's continually reading for that humidity value, that moisture in the air, which is obviously something very important that we do need to know, because air humidity, ambient moisture levels, so the humidity governs directly how these sensors work. All right, so non-invasive sensors, Tremex and this as such, do get affected by humidity. So the TurboTrack has always had a continual in the background adjustment. But what we've found with this device, because it has been tweaked to try and get us a bit more accuracy, we've found we're putting in some individual compensators for it. So since we've got a different hygrometer in here, the readings are a little bit different, and we've found that they do vary widely, whether we're going straight onto timber, straight on through plasterboard onto timber or the like. Okay, so that compensator is essentially removing the humidity out of the equation for us and giving us a bit more of an accurate reading. Now, where it does say concrete on one of those little buttons there, I would never suggest using a direct meter on concrete of a non-invasive direct meter, unless it is a specific concrete moisture sensor, which you can get, and they run at about $3,500–4,000 on it. Engineers, structural engineers, civil engineers, and the like, very common for those professionals to have it, not so much for us, okay? Which isn't really a big concern in that sense, and I'll explain why moving forward, what we can do there. Okay, now we can put a whole heap of alarms onto this device when we're using it on direct, so you don't have to look at the screen on your phone. So obviously some people don't like having two components for the moisture sensing, so now obviously you can magnet it on, so essentially it is one, so you can look at it or run the monopod and carry the phone in that hand, if you will. So you're running with the monopod standing upright, going along the wall or wherever, and you're looking at the phone. All right, so that's another way of doing it. Or if you don't want that, if you're one of those people that like to timber sound at the same time as moisture sensing, great, knock yourself out if that's your procedure, but then you haven't got enough hands to hold everything. If you're using the monopod for the moisture sensor on here, obviously it becomes very problematic to try and have your phone on there as well. So you can turn these sounds on. There's 3 different proximity alarms, if you will. And then you put your phone in the pocket. You know what your settings are that you've set each alarm to or tone to go off at. So you know, right, the first alarm has gone off. I know where between whatever percentage. And now that's all up to you to set up, okay? Because it differs. Every region is different. So moisture sensing, there's a few things we do need to understand. We need to understand the type of materials that we are testing. Going on to, obviously, softwoods to hardwoods have different profiles in them. And what I mean by different profiles is the different grain levels and porosities and density of timbers affects how much air moisture it's going to be sucking in and out. So timber is even timber in service, it's still a living, breathing creature at the end of the day. Hence, timber is one of those renewable sources on it, and it's a retainer of carbon as well, if you will, depending on which side of your environmental feelings you're running with. So it is a very good thing in that sense, but it's always going to change depending on humidity value. So even where I am here on the east coast of Queensland in Australia, my standard timber moisture measurements, so our equilibrium moisture content, or an EMC, if you will, is going to be different to someone that's running in inland Australia, or someone that's running on the subcontinent up in Asia, or even in North America. Or say, for example, Malaysia, Philippines, with that super high humidity. We're going to have differing EMCs. So it's up to us as the professional to look into what those EMCs are on site in our region. What should we be looking for? All right, having 13% or 14% in timbers in my area may not be an issue because of humidity and so forth. But going to an area where it's a very dry, arid region, the EMCs are quite low. So if you are getting 13, 14, that may be an issue. So we need to understand that for our own local region. And our own local construction materials that are used. All right, that's something I can't fully give you the answers for. I can give you the knowledge of what to look for and where to go for information, but you need to look into it specifically for your area. Now, the relative meter here, the picture, you'll notice the screen's completely different. Okay, so it's just a bar graph. And what you notice from that is we have blue or red that's coming out. What that's doing for us, that particular sensor, is only telling us if there's a difference between this area and that area. We're not worried about the percentage of moisture at that particular time. All we're worried about is there a large difference going across a certain area. There are certain materials which non-invasive style meters, this one, and also a Tremex, are purely inaccurate on. Okay, so that's when, with those materials, we move forward, excuse me, and we use the relative meter. The relative meter is still going to tell us whether we have an elevation of moisture in a particular area. All right. And that may be enough to warrant further investigation in that area. So what I'm getting at is we don't want to be caught up in percentage values here at all. All right. It's a collective thing. Again, we're the professional. We need to look a bit more into that as to what we're looking at. Don't just go on if you've just done your training course and you're in the industry and you got told to go and put the Tremex on the wall on scale 1, it beeps, scale 2, it beeps, scale 3, there you go, there's your accurate reading. That is incorrect at the end of the day. All right, so we need to do our own investigation into those things there. All right. Excuse me. Excuse me, everyone. Bit dry this morning. All right. So again, here's a screen of the direct. So obviously, doing an inspection, we want to see if there are variances going through the walls and so forth where we can't see. All right. There's no point waiting, us waiting or our clients waiting to see mold come out of wall to be told there's a moisture issue. We can see if there's a moisture issue going on in a wall void or in timbers by using these meters. So again, you're crazy not to use them. even crazier not to fully look into the relationship of moisture to timbers in your area. What this will do is we can slide it across the material as well. The Tremex is not designed to be slid across the material. It's designed to be placed going along, and it's 0.4 of a second that it needs to be held in contact with to get an accurate reading. Excuse me. However, with this device, we can slide it across the material. A steady walking pace is a sufficient speed. Not too fast. We're not running. Excuse me. And that will give us accurate readings on there. So it is going to increase or decrease immediately. Okay, the refresh rate being a digital device is very, very quick. Okay. All right, and you'll notice on the screen there, it does have humidity written on there. Obviously, that's a good record keeping as well, guys. Even now, if you're not using this, to have that on your screen in front of you, which you can save a log of too, by the way. So it's using it directly, right? We're in an elevated area, whatever percentage you deem to be elevated, for the reasons in your area and why, what moisture levels do what. Obviously, we need to know that. So it's on the screen, but then it's giving us humidity value. Why is that important? Excuse me, everyone. Just a moment, please. Okay. Again, my apologies. Okay, so why is that humidity important on your records? So if you're telling someone that there's an elevated moisture scenario, or you're saying it's not even elevated, recording what the humidity values were on that day will certainly help you if there is an issue moving forward. So what I mean by that is if it's a high humidity day and you're getting readings that are a little bit higher, so you'd be thinking, well, obviously that's a problem in there because the moisture is elevated. Well, no, not necessarily, particularly if you're using a Tremex on it, because anything above 70% humidity value with the Tremex on scale 1 is going to increase the percentage, or what you think is the percentage. Okay, it's purely doing that because it's sucking in that extra humidity, that air moisture. All right, but that's not a true and accurate reading of that moisture content using a Tremex. So you need to use the scales supplied to you in your user manual of your Tremex, which I'd like to think anyone that owns a Tremex has actually read the user manual. It's always a good start for devices. But however, it is clearly written in there. The Thermotrack, with the compensators that we have on the screen that we're looking at, that does that factoring in for us. So it's a bit more accurate in that sense. But knowing that humidity value, we can put it down. I did detect elevated moisture in this particular region, blah, blah, blah. Further investigations warranted, of course. Humidity value at the time of inspection was between whatever it may be, 75% and 80% or 85%, whatever it may be. It goes a long way for further information and record keeping as well. So the relative moisture meter. Again, all that's telling us is it's identifying different levels of values of moisture in the material in a region, but not giving us the percent. Okay, we're not worried about the percentage of the material on relative, because generally when we're using the relative meter, we're going to be using it on materials where non-invasive meters like this or a Tremex are not accurate. Now, this is why on a Tremex, scale 1 is the only scale on a Tremex that you are reading percentage of. That is the only direct scale on a Tremex. If you're using other scales than scale 1, so scales 2, 3, or the new meter where you have 3, 4, and 5 as well, all of those other than scale 1 is a comparative reading. You are not looking at percentage. If you're using scales 2 or 3 and you go, there you go, I have 10% or 11%, 13%, you're reading that device wrong. You are using it wrong. Go get your user manual and have a read of it. All right. It is not designed for that. That is not the way you should be using it. So this device, we've got two clear things, two clear screens, a relative or a direct. So think of the Termatrack, if you will. If we're on that screen now, on the screen, the direct on here, that is scale 1 on a Tremex. Now we flip over to this screen here, which is the relative on the Termatrack. That is equivalent to every other scale bar scale 1 on a Tremex. All right, where are we going to use this device? So areas where you have, for example, plasterboard might be going straight onto block work. You're going to penetrate that plasterboard into that block work. Scale 1 on a Tremex is going to give you an inaccurate reading due to the blocks. Using it on this, the Termatrack as well, it is certainly penetrating the plasterboard. And again, on direct, you will get an inaccurate reading on it. Okay, all right, so we flip over to the relative reading. On this, we take a reference point. A reference point is taken by touching anywhere on that white screen in front of you on the relative screen. It'll beep. We'll have no blue or no red on that bar graph. That has set to that level. As you move it, if we move to higher moisture area, blue will come out on the scale. And then on the screen above it, it'll tell us by a percentage of difference. So that's still not giving us the actual percentage, because we can't give an accurate percentage of that material, but we can give a difference on it because we're setting the value, moving it to the same material and getting a difference. So there's your percentage difference in that sense. But also having the humidity on the screen there goes a long way again for record keeping. So some other materials where you're not using scale 1 on a Tremex, or the direct reading on the Termatrack unit. Any FC sheeting, the old school asbestos sheeting, the composition of that material will not allow non-invasive meters, electric meters, to give you accuracy for a percentage. Concrete areas, that may come into vinyl flooring or clip block flooring, or even timber flooring laid directly onto concrete areas. You're not going to use scale 1 on a Tremex. You're not going to use a direct on this meter, because it will penetrate that timber or that flooring material, and it will then be trying to read from the concrete, and you are going to get inaccurate readings. So the direct is used for that. So using it, it's going to any area at all, referencing it to that particular material that you know a direct's not going to work accurately. Reference it and we move it. So whilst we're not going to be saying percentages at all, which technically we're not, or you shouldn't be writing down a moisture percentage value on a report as well. I can't speak for other countries, but in Australia, our documentation, as far as Australian standard guidelines go, they do not mention percentages of timber. It mentions elevated. Is there an elevation of timber within the structure? No percentages are mentioned. No percentages need to be mentioned at all. It's an elevated scenario, or no elevated moisture levels were detected at time of inspection. All right, so again, wording reporting is a different thing, and we need to be accurate on that. So don't be concerned that you're not giving a percentage reading using the relative meter. We don't need to. All right. If I go through a section here, so if this table here that I'm sitting at, if this is a section of a wall that I need to test, and I go to a random spot here, I've referenced it, and I move it, and I get an area where a lot of blue comes out, and it's telling me I've got 5%, 10% difference between reference to where I am now. That, to me, tells me I need to tell my client we have a large difference in moisture content here and here. I want to investigate further. I want to see what's going on. Why have we got that elevated moisture in there? If you get asked what the percentage is, you don't need to give a percentage. I have an isolated moisture elevation. It needs looking at, and it needs correction. All right. That's the way we should be looking into it. So there are big differences between the Tremex and the Termatrack moisture sensor. So here with the moisture, So this is just showing us how it can be utilized in a known high moisture area where you suspect or you're trying to rule out activity in that area. You get moisture, a lot of people automatically think, I've got moisture, it must be termites being that moisture. You go and put the radar on. If it's above 25%, you're getting a zero reading or a flat, close to a flat line. You go, oh, it's a moisture reading, but there's no termites in there. Well, there could be termites there, but that moisture is preventing us getting a reading. So how we go around that is by using the relative moisture meter, and we essentially are marking off the extremities of that moisture area. We're finding the boundaries of that moisture area by using this device. So referencing it in a moisture area, a known high moisture area in this scenario, then we move across. So as we're moving, it will soon as you exit that high moisture area. So if red starts to come out on our bar graph, then we slightly move it back. So we're just on that point of no red, or the red just coming out back to a clear screen. That's our extremities. We mark that, we move up a bit, move this way, that way, this way. And so we're getting a whole area of a boundary of a moisture sense area. Then we can use the radar to see whether there's activity traveling towards that moisture to utilize it, or exploit that moisture area. Or is it a carton material or bivouac that hasn't got any outward signs as yet, and it is termites retaining that moisture? If so, you're going to have some activity traveling in or out of it at some point. All right, so that's where we're working on getting around the limitation of the radar. All right. So using the relative, there is a gain function on there as well. I don't recommend going any higher than gain level 3, 4 at maximum. You will be able to see on your screen the blue or the red move. But what I've found is if we go too high on the gain, you can run into the scenario where that box is completely covered in blue or red. So what that's telling us is, yes, there's a difference, but we can't see the peak value. So when you're moving it, it'll get to the point of, right, it's already filled the box, but we could be going to a higher level, but not seeing it because our volume is turned up too high. So that's why I always recommend 2 or 3 or 4 as a maximum level. Okay. Each time you use the relative meter in a certain area, you need to re-reference it to that material. Okay. And it is as simple as touching on that white box that you can see there on the screen, on the app screen. All right. So don't go from this particular area of the house because you know it's a fiber cement sheeting or a plasterboard even, and then don't go to the other end of the house without re-referencing it, is what I'm getting at. Re-reference it to that particular section each time, and then when you move it, re-reference it again, because temperature is going to change values as well. So if you're on a northern wall, for us in the southern hemisphere, sun is on that all day long. All right, so what's going to happen there is that reading is going to be different to the southern wall. Obviously, if you're in the northern hemisphere, the stateside and so forth, that swaps. Okay, the sun's always on your northern side's the cooler side. So obviously that switches, but that's what we're looking at there. Okay. Again, we can save logs, scans, logs of the radar, but also the moisture as well. So if you happen to have an elevated area on there, you can take a snapshot of it. That can be stored as a log. You can then take a still picture through the app of that particular region or note it on your diagram or graph or however you convey that to your client. But it is good record keeping, particularly if you are finding elevation areas or elevated areas, to keep that scan as a recording. So then if you have recommended further investigation or another tradesperson to come in to rectify that situation, and they're saying it has been looked at, it has been fixed, then you can go back on a follow-up, retest exactly the same area. You've got your saved logs previously, and then you get to compare real time in front of you. So monopod. The monopod is fantastic for using when we're doing moisture sensing. Obviously, we need to check down low across baseboard skirting area, bottom plates, and so forth. So it's very handy that you can remain upright, have the monopod extended out. The monopods extend out a little over 1 metre. They're about 1.2 metres or so, or 3 to 4 feet for those of you using the imperial system. So very handy for that. Also very handy for being able to reach up high, getting onto ceilings, getting up the higher level of walls and so forth. No need to go get ladders and the like. So it does make it very easy to utilise. And also you can look at that in the respect of occupational health and safety. You're removing or relieving that stress on lower back, hamstrings and so forth on your technicians, requesting them to get down low and do that all day. But also then, there may be some technicians you have that don't like bending over low with that, or getting on their knees and doing it. So there's no excuse for them not to measure or test moisture at those levels as well. Also the very versatile tripod with the outrigger there. So that can be used for moisture. Yes, primarily that tripod will be used for a fixed position for the radar, not moisture. Okay, so temperature sensor. So this is not thermal imagery. This is purely a temperature sensor. I will explain some differences as well. So again, on the home screen, we just tap the temperature icon, and then our screen, it looks like a bar graph. So you may recall what we were just speaking about, the relative moisture. So very similar screen, just a bar. We do have blue and red coming out. On the temperature screen, though, it comes out on different sides. Moisture blue comes from the left. More moisture comes from the left, indicated by blue. On the thermal or on the temperature sensor, blue indicates a cooler area, and it comes from the right-hand side. Red indicates a warmer surface temperature, and that comes from the left side of the bar. Okay. So very, very simple to use. Again, and do remember that laser pointer that does come out from your device. At that point, don't be flicking it into anyone's eyes. Don't be going shooting planes at night, flying over the head as well. As fun as that may seem, don't do it, is my recommendation. All right, so doing temperature difference, pointing it at the material. We tap reference, so anywhere in that white screen, tap it, and it clears the screen, so there should be no blue, no red. And then above it, it's going to give us a few things. Ambient temperature, so that's obviously a big thing. Surface temperature is going to change depending on what the ambient temperature is. So again, going to from different materials to different locations, even different locations within the same structure, you need to re-reference it to that particular region at that time. Okay. And then also on the screen, it's giving us the difference in degrees. All right. That can be changed from Celsius to Fahrenheit. So if there are still people out there using that Fahrenheit scale, there is a button there to accommodate you folk as well. For the rest of us that use Celsius, it's easy. It's default. There you are. All right, so that's very handy to know, obviously, the difference. Now, the technology on this sensor is exactly the same as technology used on thermal image cameras. All right. However, this is a single pixel. All right, so it's one spot that it's registering on, single pixel, whereas a thermal imaging camera has multiple pixels. All right, goes on the resolution of the camera. So depending on what those specifications are, whether it's 360 by 240, 320 by 196, 192, whatever it may be, you times those two values together, that's how many pixels you have. So even a low-end, very low-end thermal camera, they're having 10,000 pixels. Go to a mid-range, you could be up around 60, 70,000 pixels. On the very high quality ones, you could be in excess of 250,000 pixels on the screen. So this is only a single spot temperature sensor, as opposed to thermal cameras are a multiple spot due to the pixelation. All right, so big difference. So in this, all we're getting is a reading, where the reference is, what temperature, when we move it, what the difference is. Okay, that's what we're getting on that. Where can it be used? It can be used anywhere that you feel it needs to be used. Change of temperature in materials can indicate something going on in there. It can actually even indicate a moisture problem. All right, if moisture gets into a material, it will be a cooler material because of that moisture in there. And as you heat a room up, the moisture is the last thing to leave the material. So that will remain in that material longer than areas without moisture. All right. So all of that factors into it here. And that little bit of information does help us if anyone is using a thermal imaging camera along the way as well. So there's a gain level on the temperature sensor. What that is actually doing is adjusting the surface area range. Okay, so if we're on gain level 1, for example, the surface area range is massive. It's operating within 120 degrees Celsius range. All right, what that's going to do for us on the screen, though, now, if we only get a 1 degree Celsius change in surface temperature, and we're operating on gain level 1, which is 120 degree surface range, you're only going to get a little bit of blue or a little bit of red come out on the scale, all right? Excuse me. However, on the top of the screen, we have up there a difference in the temperature range. So at this one on the screen, it's saying there's a difference of minus 0.3 of a degree Celsius and a little bit of blues come out. All right. It's the difference that we're looking at, to be honest. The movement of the red or the blue is a point of reference for our eyes. And then I always look up to see what that actual difference is on there. All right. So now if I flip over to the other end of the scale and I go up to scale 10 or gain level 10, my surface area range now is 1 degree. All right. If I move it and I have a 1 degree change in surface temperature, that whole box will be full with blue or red. All right. Not a big concern filling that box. Like I did say with the relative moisture, it is. We want to see peak values. On the temperature, because it's telling us the difference in the temperature itself on the surface, you can look at that and it's going to tell you, okay? So you can find a happy medium if you want to really integrate the blue and the red into your theories here of what you're looking at, determinations and so forth. But it's not as critical as it is on the relative moisture is what I'm getting at here, okay? Again, logs can be saved using this sensor, and then it has all of that information down there. Obviously the date, it has your unit serial number on there. It's going to tell the ambient temperature of the day and the time you were testing, and then the difference in that particular area. Again, back to home screen, hit the photo, take a picture, great, all ties in together. All right. So does it work? Yes, it does work. Are there going to be lots of areas where you find you'll need to use it? Not necessarily. You may have other ways of doing it, but it is there on the device and it can be used if you know how to use it. So again, this screen is just popping through and showing us how to set the reference, which I said earlier, have described, so very, very easy. But there's a couple of things to bear in mind when we do take that reference position and where we are positioned to the material, okay? So it works off a distance to spot ratio. That ratio is 12:1. So if we break that down, how does that work? So if we are 12 holding this device, 12 points, call those 12 points whatever you want. Call it 12 centimeters, call it 12 meters, whatever you want to. If I am 12 centimeters from the material, it is reading a 1 centimeter diameter area with that single pixel. All right. If I move further away, so I now double that. I've now gone from 12 centimeters to 24 centimeters. All right. Using a 12:1 ratio, we've now doubled it. So I've gone from a 1 centimetre diameter surface region of testing to a 2 centimetre, and so forth and so forth. So if we look at the screen down the bottom with that diagram, we're showing a 2.5 metre distance from material. It's a 210 millimetre, so 21 centimetres is the area we're going to read. 1 metre, we're an 85 millimetre, so the size of a tennis ball, for example, diameter. Where 300 millimetres, we're only 25 mils from it. All right, so you don't have to. The further away you go, it's a larger reading area. The larger reading area you're getting, because it averages the temperature within that region, there may be an issue in there, but you may not know it because you've just averaged out that temperature. So I always believe up to 1 metre maximum distance is where you want to be. Majority of the times quite a deal closer. Only 0.5 metre, 500 millimetres, and then we're running around that 30 millimetre size. To me, that's a good size because you can be on studs, pick up that leading edge of studs, which are predominantly 35 millimetres on small edge. So you can go onto that, and then you can go beside it off the stud, and you can see the differential between those straight away, which is a good thing. So it also helps us to see how timber is an insulator, as opposed to bare plasterboard. Now, when we do pick our distance to spot, I reference it. I can't stand in this position and just scan the room by spinning around like this. The reason is I'm then going to be continually changing my distance to spot. All right. So when I'm square on in front of it, whatever distance that is, when I go to test, I need to remain parallel to the wall, moving up, down, vertically, diagonally, whatever it may be. If I reference it and I'm 1 metre from the material, I need to test down that end of the wall and everywhere else in that area at that 1 metre interval. All right. If I stand in the middle of the room and spin around like a ballerina, obviously angles. As I move over there, I'm no longer 1 metre from that material. I'm 2.5 metres. I'm 3 metres perhaps. And then I get back to the next opposing wall over there. That distance to spot's getting shorter. And then I get to the next corner. It gets longer and longer and shorter and shorter. So you don't use it like that. You don't stand there just spinning it around. And coincidentally, if you have utilized or are utilizing a thermal image camera, that is exactly the same. You do not stand there and just spin around. That is not the way to use those devices either. And that's why if you are using a thermal image camera, the recommendation always is go into an official thermography course. Learn how to use that device correctly, not just looking at a pretty picture and think that you know what you're doing. All right. Because when you go to do one of those thermography courses, you'll realize how little you actually know about a thermal image camera. So it's safety for you for not getting sued, and it's also safety for your client to use that tool correctly. Okay. So back to here on the screen, running into that distance to spot. So it's a very big thing. All right. It doesn't really matter how fast you move it if you're looking at your phone, because it will instantly change. All right. But obviously, again, you don't want to be seen that you're rushing through a job and so forth, because the device may not miss the issue, but you will. All right. So keep your head on task. Keep yourself moving how you should be to retain information or notice information. So just moving it nice and steadily, parallel. If you need to move down that end of the wall, physically walk down that end of the wall. Don't stand there and just spin it around. Okay. So again, it's about using it how it should be used to give us the best information possible. Any tool can be used incorrectly and give you the results that you think you want to see. That's fine if you want to do it that way. I prefer to use whatever equipment I have in such a manner that it's going to give me what I need, not what I want or what I think I need, but what I actually want. All right. Okay, so we'll look at the thermal camera side of things. On the Itraker now. Now with this, if you've already got one, you'll know this scenario. if you haven't got one and you like to order one, at this point we do need to know whether you'll be using an Android device or whether it's an iOS or so an Apple device, because physically the components are different. So we need to know which one you want to use there. Okay. All right. So the app screen, obviously, as I said, it will be on the main screen there of the app. If it's a Pro model, that thermal camera, when connected, that icon will be in white, not in grey. So we're tapping onto it to opening the thermal camera. We do need to use a cable at this point in between our device and the eye tracker for the camera. So that prevents any lag that may happen through a Wi-Fi channel as such, so through information sharing between the devices. So a cable is needed. It gets plugged into the eye tracker and then gets plugged into your phone port. So this is where you can utilize the magnet. As you can see in this picture here, utilizing the magnet on the back of the device, you can have that all in front of you if you like. Well, the cable is long enough as well that you can hold one in each hand. It's whatever you're more comfortable with at that point. So when you do connect the thermal camera cables and you go to open the icon, it will ask for permission to the camera. So that's just a quick yes, and then it'll open up for you. Okay. Now with thermal imagery, because there is quite a lot involved with thermal imagery. It's not just a matter of opening a device that has an IR camera in it, pointing it at material and looking at different colors, if there is any different colors, and then making an assumption about what you're looking at. There is a whole bunch of physics involved, a whole lot of equations and calculations that we should be doing, and settings should be getting adjusted quite frequently. There should never be a set and forget type setting. Whilst a lot of materials we use are very, very similar, so we can come up with average settings for certain type of materials or constant materials. Realistically, as a thermographer, we should be looking into doing all of these sort of tests when we're doing it. So as a standpoint, any training today as far as the thermal image camera, it is not thermography training. Okay, it is purely a how to use the thermal imaging camera on the eye tracker. I will run through some base physics of it and some base calculations for field of view and so forth to use. But we always recommend that you do seek your own thermography training. Okay, there's quite a few places, a few businesses around that do the training, and you do come out as a level 1 certified thermographer. Okay, which currently I am on it. It's thermography training is not about training you to be a pest controller. It's not about training you to be an electrician or a diesel fitter or a hydraulics fitter. It's about training you how thermography works, how to use the thermal imaging cameras, and then you apply that to your specialized field or trade. Okay, so it is very good training. It is highly in depth, and you learn a whole bunch out of it. To be honest, prior to me doing the certification training, I thought I knew a little bit about thermography, but I was incredibly wrong. First day into the week course, I knew how little I actually knew about thermography and infrared radiation. So it's well worth doing. And we do, and also as a suggestion is if you are utilizing thermal imagery within your business, whether it's the eye tracker or any other particular thermal imaging camera that you may have or access to, yeah, it is also worth having a chat to your insurer about it as far as qualifications, do's and don'ts, as far as reporting and so forth go. Because like anything, we do need to have an understanding of what the tool is, the device we're using. We should have a thorough understanding of that, and our clients have a reasonable expectation to believe that we're knowledgeable and qualified in the use of any equipment that we bring into their premises. So please do your own investigations. You can see on the screen there's a few places where you can go and do those thermography courses. Some of them you can do face-to-face, otherwise online. And as I said, it's a pretty intensive course. It's a full-on 40 hours with exams, two staging of exams through the course as well. So it's a lot involved, lots of homework to get through it, but highly beneficial. So what we'll do with this, and a lot of this what we're talking about here is it's to get our terminology correct and what we're going to talk about to customers or even amongst yourself when you're using it. So with that, to move forward, we need to understand what the first law of infrared thermography is. So, and this is what we have here on the screen. Okay, so infrared instruments detect infrared radiation from the first 1,000th of an inch. So that's 0.0254 millimeters. So it's the paint layer of the material. Essentially, is the thickness of radiation that's detected. Okay, so there's no penetration of materials other than that depth. Doesn't go through walls, does not see through walls. It is not X-ray vision. We need to understand that. So because it only detects infrared radiation, they do not measure or see temperature, and they do not see through most solids or liquids. All right. It is calculating what the temperature is from the amount of infrared radiation that it gets from the surface on that limited amount. We are not looking for hotspots. Right? We are looking for thermal differences. It's a big thing in thermography about hotspots, and quite a bit of physics comes involved. If you look at something on the screen and you believe, oh, there's a hotspot. Okay, yes, there are hotspots that we can view on certain things. If we're looking at electrical components and so forth, yes, then you're looking for a hotspot, but we're not. In building scenario, we're not looking for hotspots. We're looking for thermal differences on the materials within the building structure. So terminology is everything when it comes down to the tools we use, and in particular thermography. So there is lots of physics involved with thermography. There's 5 areas of physics. So we've got mechanics, we've got thermodynamics, electromagnetism, relativity, and quantum mechanics. Okay, so generally though, with what we're doing as far as building and pest inspections, relates to thermodynamics side of physics pretty much. Okay, so thermodynamics, it deals with heat and temperature, essentially how the behavior of a large number of particles are working. Okay, so being able to see those thermal differences, that's essentially where it's at for us. It's the thermodynamics moving across the building material. So the definition getting as well of infrared thermography. So it's the collection and analysis of radiated electromagnetic energy in the infrared portion. So as you can see, there's lots of big words here and lots of it gets all tied in together and we keep talking along. All right. So it's different levels of the radiated energy from a particular field of view or a scene that we're viewing. It's displayed as different colors on a video monitor. So that's it. So it's measuring that radiated energy given off from the first 1,000th of an inch of the surface of an object. All right. So it's not measuring that temperature at all. It's measuring the radiated energy and then it gets calculated within the processor as well. So the onboard computer, if you will, which this is an imaging radiometer, and they are built in internally. So it's all one big calculation for the device. Okay, so it is not reading temperature. It is measuring radiated energy and then calculating that into a temperature reading. So when we look at temperature, and this really gets us down to our terminology that people use of looking for hot spots and so forth. What we're doing, so we need to have a look at the basics of temperature and the concepts of it. As many people confuse temperature with the concept of hot and cold. All right, so it's the perception of hot and cold is a relative idea, while the concept of temperature is defined. It's an exact value that doesn't change under relative conditions. It's the concept of confusing hot and cold, or the perception of hot and cold, to temperature. So if we give it just a basic analogy here, it makes us understand what we're thinking of as far as temperature, hot, cold, and then we can apply that to how we use thermal imaging cameras. So if we look at a scenario, the room we're currently sitting in is 22 degrees. Now, if we come into that room from outside in summer, depending on where you are, can be very high temperatures, of course. So let's just assume the ambient temperature of this summer particular day is 40 degrees Celsius. The air conditioning set it with inside the building at 22. When you move from outside to inside, the room's going to feel quite cool. You might want to put on a sweater or a jumper or another shirt or something like that. Now, the room's still 22 and we move into winter. The outside temperature maybe 20 degrees or less, maybe 10 degrees Celsius outside. So then when we enter that room, remembering that room still has the same temperature of 22 degrees Celsius as our first scenario, when we walk into that room, the room would feel hot because we've come from cooler weather outside. So what we're looking at there, the temperature of each room in each scenario has remained constant. However, it feels cold in one example and it feels hot in the other, but the temperature is exactly the same in both examples. So what is temperature? So definition here is heat is kinetic energy in transit from a higher temperature object to a lower temperature object. That happens purely as a consequence of temperature difference only. So hence, that's where we get the feeling of the hot and cold, but we need to distinguish between hot, cold, and temperature. So as you can see from that, it's if you can get your head around that little analogy there, which on the surface can be quite confusing, admittedly, but once you think about that for a moment, it starts to make a little bit more sense. And then you can start to see that relationship and why we say we're not looking for hot spots, we're looking for thermal differences. So temperature difference between the molecules. So when heat is an energy in transit, it will always flow from a higher temperature object to an area with lower temperature, or another object with lower temperature. All right, so all objects contain internal thermal energy. It's not heat, but thermal energy. Right? Cooling decreases an object's internal thermal energy, while heating adds thermal energy while increasing it, basically. So two objects are different contact, or two objects with different temperature, internal thermal energy and temperatures, when they contact each other, the heat will flow from the hotter to the cooler object. Over time, they will reach a common equilibrium, and no more heat will flow between those two objects. So all objects naturally are trying to seek a thermal equilibrium with where they are. Okay, so we can utilize that knowledge when we are using the camera. What is the ambient? What are we trying to achieve, or what are we trying to hopefully locate by utilizing a thermal imaging camera? So do we need to manipulate that thermal energy within the room before we use it? All right, so once that starts coming into play, into our mind, then we can associate, right, well, if everything needs to change from a higher temperature to a cooler temperature to achieve equilibrium, this is how we're going to show some differences. So if there's moisture in a particular area of a building material, that temperature shift between that moist material to right beside it, same material that isn't got the moisture in it, the heat is retained in that moisture area, different to the material which does not have the moisture in it. So that is where we get surface anomalies or thermal anomalies on the surface itself. So manipulating the environment in the structure or the building that you're going to do your inspection in prior to you arriving on site is where we want to look at. Okay, now what I'm meaning by that is if it's winter and you go into a building where an air conditioning unit is running the way they are intended to condition the air, not cool it, but condition it. So air conditioners work more efficiently by running continuously. We're not cooling the air, not coming home from work and going, the house is cold, I better turn my air conditioning unit on now, makes it all nice and warm. All that's doing is making the air warm or warmer, right? Using a hell of a lot of power in the process to do that. Whereas if the air conditioning unit is left on all day, what happens is it will eventually equalize every object within that room. So the flooring, the walls, the ceiling, the furniture, everything will become that temperature that you've set your air conditioning unit at. So there's the equilibrium. So obviously, if you are trying to find anomalies on the surface in that scenario, you wouldn't, because everything is equalized. So for example, what you can do, going out particularly winter to your clients, knowing you've got an early morning inspection, for example, you utilize the thermal imaging camera for moisture investigation, for example. What you want to tell your client is, or ask your client, have you had the heater on all night, or has that been running consistently 24/7? Well, it has. Okay. Prior to my arrival, which is going to be 8 a.m. or 9 a.m., whatever it is, 1 hour before my arrival, can you turn that air conditioner or that heater off? So what that's going to enable then, it's going to enable the kinetic energy of the heat moving from object to object differently again, because different objects change its and retain thermal energy, internal thermal energy different. So we have a chance then of picking up a variance. For example, in that scenario, moisture retains heat or higher thermal energy longer than material that doesn't. So looking for those hotspots, or not hotspots, are thermal differences, particularly if it's a moisture problem. Having that heater turned off, everything starts cooling down or getting to a lower surface temperature, but that moisture area will retain that for longer. So that will show up on our screen a lot easier because we've removed that equilibrium. All right. So hopefully you're sort of starting to see here as well that it is more than just grabbing a machine, pulling it out of the box, turning it on, pointing it at the wall, looking at a pretty picture. We do need to fully understand what we're looking at on that pretty little picture and why it's doing that for us. So these are part of the things that we need to get our mind around. So there is quite a bit in it involved. Okay, so hence the technicalities that come in of using infrared technology and thermal imaging cameras. So again, the recommendation always is an official thermography course. Okay. All right. So the actual camera on our device and the or the infrared imager and the camera resolution. All right. So the image on the screen, it's composed of many pixels. The temperature sensor, as I said, it's a single pixel. So it's the same as like a thermometer, if you will, which became quite common during COVID, the spicy flu era. If you can remember those crazy times, going into buildings and everything, people would put these thermometers on your head. That's it. It's a single pixel calculating what your temperature is. On the thermal imaging camera, it's made up of multiple pixels due to the viewing resolution. So the viewing resolution of the camera within the Itraker, it's a 256 horizontal view by 192 vertical view. So you times that together and we come up with just under 50,000 pixels. That's what we're looking at as far as the resolution goes. Okay, so to give you an indication, quality, if we do a comparison here in purely on resolution specs, we're a little bit above a FLIR E6 and we're a little bit below a FLIR E8. Okay, so we're not a top line thermal imaging camera here. And Termtrek was never claiming that this was going to be the case either. It's just a handy addition to our arsenal on there, but it is certainly well above a lot of the cheaper clip-on thermal images that people can get out, or the FLIR C3s and C4s. They're quite down there in specs. So we are well above those into a very usable level. Now, where a lot of confusion in how to use thermal imaging cameras is where to stand. How far away? Can you be parallel? Can you be on an angle? And so forth. The easiest way to answer that is you can be at whatever distance, whatever angle you like to be, as long as your settings are correct. Hence, getting the settings correct, that's where it does go into the thermography side of training. I'll give you explain what the settings are here for you, and show you looking at and try to explain calculation wise here as to how we achieve what field of view we want to be on. All right, so the total area that is seen by the camera is defined as the field of view, or the FOV angle. So that's provided by the lens itself. So on the Itraker, we have a 42 by 32.1 degree on there. So what we need to do, though, from that to get your field of view, we need to change things into radians. Okay, changing into radians, simple calculation, simple formulas here, as you can see. So we've got the horizontal of 42. We times that by 0.0175, which is radians. So we end up with 0.735 radians on the horizontal, and then we end up with 0.56175 on the vertical with radians. Okay, so when we're looking at that, the field of view is the angular length in radians times by the distance. So moving down the calculations again, our horizontal 0.735 milliradians. Radians that we have, if we times it by a distance of 1.5 meters, we're going to have a 1.1 horizontal field of view, meter horizontal. The vertical field of view from our previous calculation, which got us to 0.56 milliradians, at the same distance, 1.5, it's going to give us 0.8 of a meter. So if we look at that, if we're 1.5 meters from the material, we're going to have a 1.1 by 0.8 field of view. Okay, that's at a distance of 1.5 meters. So the instantaneous field of view, So what that comes into is it gets down to accurate measurements of temperatures and so forth. Easiest way, so it is a 2.4 milliradian camera. So the spot size is actually, to getting that, we're using an IFOV, which is instantaneous field of view, in milliradians times by the distance. So in this instance, we can go 2.4 milliradians by 3, which is getting us down to 7.2 millimeters. So at a distance of 3 meters, we can accurately read the temperature of a spot 7.2 millimeters small. All right. Now with us though, we technically are not doing qualitative research, we're doing quantitative. So the difference between it is, do we need to analyze particular temperature of the components that we're testing? Not necessarily. Okay. We're looking for a more broad differences in the thermal energy. So that's a quantitative. If we're getting into qualitative research, that would be getting into more finite things. Power transmission lines, transformers, electrical components, switchboards, and so forth, hydraulic rams, motors. That's the qualitative. That's where the exact temperature is highly critical. For us, not so much in that sense, okay? So again, there's quite a bit involved, but having those basics there, in that sense, those basic formulations, straight away, then you can see, well, if we move further away, that gets larger. Obviously, the viewing area gets larger. All right. So again, it's a calculation to be able to use it to what distance to know what you're actually looking at. All right, so getting into measurable field of views. Again, that's what we're talking about, seeing the exact temperature of small areas and so forth. So again, we've gone from having a field of view measurement and now we've moved it to a instantaneous field of view. And now this one, we're talking about the instantaneous measurable field of view. So essentially, it is the IFOV divided by 4. All right, so 0.6 milliradian. So if we want to look at an object that's 5 mil in size with the eye tracker, so it's got an IFOV of 2.4, which we had a look previous page calculations, furthest away that we could look at and calculate accurate temperature for 5 millimeter size is at 2.8 meters from the surface. All right, but to make a highly calculated calculation for temperature, we've got to be 4 times closer, which is 0.52 of a meter. So again, you can see we're never going to work at 0.52 of a meter away from the material. We don't need to. If I had a switchboard in front of us and I wanted to have a look at that little connector 2 rows in behind the RCDs, and I want to see what that particular that connector is giving me a temperature of, or radiated energy temperature, that's where these calculations really come into play. Okay. So again, a lot of this is to make you understand how much is involved in a thermal image camera in relation to what we're actually looking at. All right. So that's where we're at. We're doing different inspections here. All right. So connecting it, we do have a cable, as I said, to connect the two up. It is a USB C cable at both ends. There will be a specific cable put in your kit for the use of the for the thermal imaging camera. And as I said earlier, we do need to know whether it's iOS or Android system that you are running with. All right, so we tap on thermal imaging icon. Again, it'll ask for permission for us. Tap it again, opens up. So this is the screen, the main screen they're going to look once we are connected. They can see on the left here, we can see that the thermogram does show up. We've got the isotherm on the right-hand side. And then we have 5 different color palettes to choose from. And then there's a whole bunch of settings that we can use. So looking at that picture on the right, so that is just a basic view of a keyboard, as you can see there. That was just to show you the variances in the calculated temperature going through using it on a color palette there. Again, we're just using the same picture through, so it gives us that large variance so that we can see what's happening. Excuse me. All right, so the bottom right of the screen there, you see those little lines, dots. That's a setting button. There's lots of useful settings in and amongst this area here. So as we go down, we can see the correction, we can see reflection, ambient, humidity, emissivity, and distance. So distance is a big one. So obviously, if you are in particular areas, depending on what you've done your calculations, if you want, but generally, as you can see from that calculation, roughly around the 2 to 3 meter mark is sufficient for what we're doing. Again, we're not getting down to the exact temperatures. It's more of the broad view and the field of view. So distance does come into it a whole bunch there. All right, so do look at that. Moving up on those, obviously emissivity. What that is materials or an object's ability to reflect infrared radiation. That's all it is. Comes into play. Every material has its own sort of emissivity rating. Higher smooth, higher glossy, the lower the emissivity rating is. All right, so it all comes into that infrared radiation or thermal energy being retained. Okay, so the more matte that you go, the higher that number gets. And then we get up to 0.98 is the maximum of the emissivity which we want to run at. All right, so standard on it, generally speaking, if you're looking at people, we're at 0.98. Then as you go down to materials and so forth, getting right down to glossy materials, say glass, for example, or stainless steel even, getting to it, you're getting right down to 0.15 emissivity. So that can be large variances playing onto our thermogram, but also temperature readings if you're looking into temperature readings. Humidity, obviously, that's a big factor in what we're doing and can change results on the screen as well. Humidity reading, there is a built-in hygrometer on the ThermoTrack, on the Itraker. So the moisture screen, relative moisture screen, has that on there. So you can utilize that if you like, or if you do have a decent weather app on your phone, you can use that as well. Obviously, ambient temperature, so the room we're in, change that. If that's a mass difference to that setting to what it actually is, you will get a big difference, because what it's doing by having incorrect readings in the settings is it's throwing out the onboard computer for it to make its calculation from that radiated energy, putting it into temperature for us. Reflection. Now, reflection is a big one here. So what that is telling us is whichever way you have the camera pointing at the material, think of throwing a ball in that line or bouncing a ball to that direction. Where does the ball go to? So if you're standing right in front of an object and you throw the ball at the wall, it's going to come straight back to you. So depending on your position from the material, depending on the emissivity rating of that material, depends on how much reflective radiated energy from you is coming into that equation, okay, or coming on the screen. So obviously, the lower emissivity rating, so we're using, if you're looking at more gloss material, smooth, shiny finishes, that reflected energy of us is going to come into a greater play. If you're standing on an angle, pointing to the wall, again, bouncing ball theory, throw it on that angle, which way does the ball go? So think of playing snooker, if you will. You need to use the cushions to get your angles. So you hit on an angle, hit that part of the cushion, it goes off at the equal angle, going out unless you put spin or screw or hook on it or whatever it may be. But if it's a straight up bang, it's going to move at 90 degrees from that cushion. That's what essentially we're looking at here, the bouncing ball theory. So if you have a window on the opposing wall, you're an angle, you could be getting that sunlight coming in and giving us that reflective temperature and so forth. Could be a moat, could be a fridge right beside it, the wall blowing hot air out from fridge motor and so forth. So all that's got to come into play in there as well. So really looking in and setting that up. Now the correction temperature there, my advice is we don't really need to worry about that one. Leave that at the factory default, purely because that comes into play if you know your full calculations for setting up emissivity, the relationship from that to reflective temperature and the ambient temperature as well. So then we can correct to take out those, let's say, over the top readings, which may affect our results. But for what we're doing, and in these scenarios, my suggestion is don't worry about the correction at this point. Just look at your base ones. As I say, no reflection or limited reflective material, your higher emissivity. So 0.98 is fine. And the shinier you go, the more you come down on the number of that as well. So again, all of that, there is calculations and tests to do on materials with a black body to give you exact emissivity ratings. Again, you can do some quick base tests with those, the knowledge of the IFOV and IMFOV and so forth for that to help you out. But again, this points us towards there's so much involved with thermal imagery to get it correct. All right, so settings, we've just run through that for you. Already explained what's happening with those. Now, hitting the color circle wheel, the main screen, that brings up, we've got the 5 different palettes here. So left to right, the screen we're going, so that's showing white is hot. And then we move into an inverse, so black becomes hot, or higher temperature mode, if you will. And then we go into rainbow. So the rainbow ones just purely sort of come into the more varying materials you have in a particular area. So that particularly comes into play. For example, using Rainbow 3, that's very good for utilizing in switchboards and hydraulic motors and such, because you're getting those different crisping change from colors. Whereas the grayscale is more for more sweeping changes. So like what we do, if there's a moisture buildup within building material, for example, and we've done our ambient equalization or equilibrium, and then heats off and so forth to getting that slow change, that's when we start picking those up. Again, I personally prefer using the gray modes, the grayscale, so the white hot or the black hot. Generally, it's the white hot mode that I am using it for. I do find for what we do, that tends to be a little bit more accurate because you can see those slight shading changes, not just a crisp color change, okay? But again, it's how you prefer to use it with your knowledge of thermography and what result you're trying to achieve. You can make up your own mind on which palette to actually use. Okay, so you'll see on the bottom of the screen as well, we do have what looks like a temperature button. So going on to that, what that's doing is then going to open up our isotherm scale, or our temp gradient span, if you will. So at this point, the camera, what we have here with the isotherm, we've got 3 measurements. So we get our, wherever our crosshair is, so we get our center spot surface temperature, and then it's going to give us the lowest temperature within our field of view, and then it'll also give us the highest temperature reading within our field of view. So that's all within the field of view. Okay, so that's not an adjustable span on here. So out of all the specs and everything come, realistically for us, this is really all we sort of need to know at this point in time. If we're getting into more detailed researcher components and so forth. Yes, having different temperature views, marking the maximum position, marking the lowest position, things like that do come in handy. But for what we're doing, it may be a little bit too much as far as settings go and so forth. So this has kept it nice and simple, but giving us the information that we need. Now, if you're keeping thermal scans in any way, so hitting the save button, we can on each sensor. I do recommend to have the isotherm scale on the screen. But do bear in mind, though, if you are saving any thermograms, so these screens here at all, and commenting on thermal imagery, make sure you've got all your calculated information as far as your setup is concerned. Okay, these are the things that, if you are adding these to your reports, and you're doing the qualitative research, if you will, commenting temperatures and what this is and that is, and the reasons or possibilities for reasons why. If something's wrong, or you've misdiagnosed it, you've created some grief for your client by telling him to cut a hole and there's nothing there, for example. It can be as simple as that. Or you missing something, for example. If you get taken to task over it, this is where you're going to need all that information to back you up. If you're not a qualified thermographer, straight away question marks from expert witnesses will be placed upon us. If you have all your calculations leading into that point on it, at least that does show you have an understanding of thermal imagery, and you can prove why you've got to this point and why these temperatures on the screen we're looking at should be fairly accurate. All right, so again, I'm not trying to scare people from using thermal image camera, but really we need to understand how to use it, what we're looking at, and how we convey that to our clients. All right, so capturing an image, very simple. And this is on any sensor that we're using at the time. Hitting that save button, it will automatically capture that. We can then go in, we can just save that to local storage. Look, it will save to app, but it'll also then open up a gallery or an album within your gallery, or on that device, your phone that you're using at the time as well, which does make it very, very handy in that sense. Okay. All right, so saving data, viewing jobs. You don't have to. Back in the early days of ThermaTrack, even prior to the T3i or early days T3i, if you wanted to save any data, you would have to upload jobs. And then when you went to use the device, you'd have to open that job and use it. Well, we don't have to do that anymore. It's a matter of just get out there, use it. If you see something, whatever sensor you're using that you want to save to your portal, or even just for the pictures, onto your device, and then you can JPEG them. So they're saved in JPEG format that can be used on your standard inspection reports as well. So if you're doing those things, it's as simple as hitting the save button. So you'll see the save button on the phone there on the screen. You're happy with what you've got, doesn't matter what sensor, hit that save button and then it'll come up on there. Okay, so it'll say, right, where's it being saved? You can go further. You can hit another button there and you can start typing in some things of the customer details, addresses, what room were you in testing it? Was it handheld? Was it fixed? And things like that. You can add all that extra in if you want while you're there on site. You don't have to. And then there is an upload button there that you can press as well. Now, there should be an automatic upload to cloud if you have a reception on your phone. So if you've got a SIM card in there, in your cell phone or your tablet, whatever it may be, it should automatically upload. If it hasn't, then we need to do it ourselves by hitting that upload, and then it'll tell us when that has happened. So from that, once we've got that on the screen, it's just saved into our system. That's up in cloud and always stays on your device. Then it's just purely a matter of opening that up on your device, and you can see on the right picture there where you can then go and draw all over it on that screen. So then again, you can download it straight away onto your device, upload cloud, or you can share that picture straight away, the same as you would with your regular phone. You're taking a snap of the beer you've just had with lunch or whatever it may be, and then you can share it off to your friends and so forth. So with this device, it has been a little bit more integrated to make that a bit more user-friendly for us for the collation of information and where it's stored. Okay. But if you are saving it through to go up as an upload to cloud, it will prompt a few things you have to fill in. All right, so that's nice and easy in front of you. It says, right, these field asterisks, you must fill this section in. So very simple. Now, you don't have to do that on site. You can get it saved to here, and then once you're back in your office or sitting in the air conditioning in your car or the heater on your car, whatever it may be, or down the pub, then you can go through it and you can upload that up to your cloud if you want. And then from cloud, you can manipulate anything you like from there. You can add extra stuff onto it, still pictures of damage or whatever it may be. Okay. So it is a very simple process. Cloud storage is free on the surface. However, we are paying that subscription. So the monthly or the annual subscription, how it gets set up on there, and that pays for any of the back end work or advancements or improvements that need to happen on the cloud system as well. But you're not going to get charged for the amount of data that you're storing in the cloud. Okay, there's a hell of a lot of data to even get 2 gig of data into your cloud. All right. So don't be too concerned by how much you're saving. All right. So if we finish using the device, very simple. From the home screen, you just tap the exit button. It will ask you twice. All right. So in case you've got fat fingers and you've accidentally bumped the button, it will ask you yes or no. All right, so same as most devices we know now, even our phones, you go to hard turn them off, it comes up with, what do you want to do? Turn it off, refresh or cancel, pretty much the same here. So tap exit, exit box shows up, hit yes again, that shuts your app down, disconnects it from your eye tracker, and then you just need to tap your power button to take the green light off to a dead situation. All right, obviously put it back in your kit, and then away you go for tomorrow. All right, so the online reporting through your customer portal. So that's you as such. Obviously, when you sign up with ThermaTrack, part of that, you will be set up with it. It's generally your business name is your user. You will be self-generated a password, temporary password. You log on, you can go through and adjust all of that. Obviously, you use that password, so forth. But every ThermaTrack you have registered to your business or yourself will show up in the online portal. All right, it'll come up straight away what business it is, what units you have registered to your business, and then you can go down the list and look at whatever. Follow your serial numbers. You go, right, I know Noel's got that one. I want to have a look at his stuff. Click on it. It'll show up any saved logs from my device. All right. Now, from there, you can do supplementary test reports. Look, in Australia here, we have a ton of paperwork that we have to do. It is the thorn in my side. I don't know about anyone else, but I hate it. So, look, doing a little bit more paperwork at times can be a hair-tearing situation. I get it. If you have staff members, office admin, whatever it may be, that are able to do this sort of thing for you, fantastic. It's a great little addition to give your clients this type of thing. A lot of people, however, are using the photos they save or the logs that they save and adding it onto our standard reports, which you can drag and drop over depending on what device you're using for your reports. That's fine. That's quite okay to do. It's your prerogative. Some people do like the supplementary ThermaTrack test report because it's a standalone document with all of the ThermaTrack stuff in there. and no one else, and a lot of people don't offer that. So it can give you a little bit of a distinction over other people. So look, here's your ThermoTrack report. Or if you're going in on a invasive inspection or a special purpose inspection after your basic inspection, and you've told the client, look, this is what I'm going to be doing. I'm going to be using this device going through all of this area. Well, sure, you can say part of the cost of me doing that is also supplying a ThermoTrack report in a standalone document as well. So obviously, if you're going that line, hey, look, charge for your time to do it. Charge a little bit extra. Clients may see the value that you've given them something more in a more easy to read format with only the details on there of what you were just doing. Obviously, depending on which part of the world you're in, you're governed by legislation of your country, so you still need to do that. Us in Australia, if we do a treatment or a further investigation, we then need to give a particular report or certificate for that. In addition, if you want to give the ThermoTrack reports as well, okay? So it is all very easy. There are specific some user guides and instructions through the ThermoTrack website, and also linked to YouTube, and they're easy, follow along. So you can open up your portal on your computer in your office, and watching the step-by-step guide as well if you're unsure. But it is fairly self-explanatory on there. I don't know technology for computers on it, and I can get through it pretty good. I don't need to go to my kids for help on that one. Now you can add on your company logos, extra photos, logs, all of that type of thing can be on there. Okay. I said it right at the start. We are the pro on site. These things are our companion tools. All right. These aren't doing the job. We are. All right. So there's a few things we need to know, obviously. We need to know the property. What construction is it? Steel, timber frame, slab on ground, are we on stumps, crawl space? Do we have gardens up beside it? You're doing the standard things. What areas on this property am I looking at that it's going to be a critical area? So you may want to look at a particular area, even with no other sign or evidence of termites, you may want to use the radar in a particular area. And that comes from your experience, not only within the industry, but your experience and knowledge of construction techniques and so forth. All right. So you don't have to go through the whole house, or you can go, right, there's no evidence of anywhere I don't need to use the ThermoTrack as such on radar, but there may be a few scenarios from experience that tells you I want to check that area. All right. And you can do it non-invasively. All right. So do your standard visual inspection techniques, go through as per normal. When I go through, I'm not even thinking about where am I going to cut a hole in the wall to look or put a camera in, or where am I going to use the radar. I'm not thinking about that. I'm looking at it, anything that I'm looking at as I normally would. And if something jumps out, well, then I use the appropriate tool. Now, when I go in and start my inspections, I have my ThermoTrack with me straight away because that's my moisture sensor. All right, I'm going through and doing that. If I need to flick over to a radar or use the thermal, whatever it may be, it's a couple of taps on my screen. I've got it right there. It's in my pocket. It's in my hand. I can use it very quickly moving forward in whatever sensor. So to me, that saves time. I'm not having to go out to the truck to get a different tool. I'm not only using a tool, Tremex, for example, that only does that. If I want to look further, oh, gee, I've got to go get this now or get that. ThermoTrack, it's all there in my pocket. So it's a great companion tool in that sense. All right, so we locate our areas visually of concern, but utilizing whatever sensor we need to pinpoint it down to any abnormalities or anything that jumps out looking not quite right. Obviously, if we detect activity or elevated moisture or a temperature differential on surface enough, you can quickly use these sensors to give you a little bit. You're not needing permission from a client to throw the radar on the wall and so forth. Right? So you can do that to get you a bit more information, but obviously we need to always suggest to the client or recommend we need further investigation. Because let's face it, if you go in to do your inspection today, they're only paying for that inspection. They're not paying for any steps further. So don't do your dough. Always charge for your time. You're using professional equipment, charge accordingly. Don't go out and do inspections for free. That's just crazy. All right, that's how that ever happened throughout the industry in times I don't understand, but let's just move forward from doing that for free. We want people to know that we're professional in this industry. We have the tools now, we have the technology and the knowledge. People need to recompense us for that, as far as I'm concerned. Don't give your time away.